Oh, whoa. Equations. Oi. Don't freak out. It's just an equation, nothing more. Try to understand what is in this equation. I show you on the next slide that this equation actually describes all the type of different shapes of salinity distributions that you can have in positive estuaries. So what's in there? There are two variables in there. One is the salinity ratio. Okay, it's this we discussed that before. It's the vertically average salinity divided by the seawater salinity. Okay, and this depends on the location. Okay, where is location? On the right hand side is an exponential function, and it has an argument. And inside the argument, there's the other variable. Here you can see x is distance divided by length, but it's on its head. It's the inverse of normalized distance. Here, L over x. And there is one parameter called capital F that determines the shape. It's only this F here which determines the shape of your function. Okay? And then you can go one step further. And this goes back to Ahrens and Stommel from more than 70 years ago. They looked at these shapes and they determined, they derived this function. So now what's the F? Okay, F is some constant. Okay, it has some other parameters like the mean depth, which is this H here. It has the tidal range, and this is at the estuary mouth, tidal range. But now comes the important point. There is the R over V ratio in here. This determines the magnitude, or this varies the magnitude of F, because R, as you already learned, is the inflow of river water, the volume of it per tidal cycle. It's the river discharge rate, okay, the volume transport into your estuary. This is R. V is the tidal range, it's the tidal volume. It's the volume change of water introduced during a tidal cycle. And V again is also a constant for a given estuary. So the only thing that really only changes is R. Okay, so the R, the amount of river runoff into your estuary, controls the shape of the salinity distribution in your estuary. Wow. Okay, so if you see an equation, okay, don't freak out, don't run away. Yeah, you can. Okay, all right, you can run away, but you have to come back, look at it, and try to master it. By mastering, I mean get a feeling for what are the variables, what do you actually want to get? Okay? What are the parameters? What controls the shape? Okay? Also, what you know, you should know that it's an equation actually is what's on the right side of the equation is exactly the same as what's on the left side of the. We come to that later on because we want to manipulate this equation a little bit further. Okay, so this is the, so now, wow, so much talk, but now I show you the evidence of what does this equation do. You can produce curves. And this is a diagram that shows a number of range, a number of curves, and each curve is for a different value of F, this parameter. Okay, so you can get an idea. On one side you have this is your estuary head, 0, and 1 is the estuary mouth again. This is normalized distance on the x-axis, and the y-axis shows you the salinity ratio. 0 is the freshwater environment, 1 is the seawater environment, and then you have sort of different type of curves. You know, you can have a linear curve in the middle, Okay, that is somehow in between. And then you have either convex or concave curves. Okay? And it all depends on the F. If the F value is very low, which means you have a very low freshwater river runoff, compared to the tidal volume, you get a curve here shown in this example here, 0.008 is the value. And this is a vertically mixed estuary. And if you have a high river discharge, you come to salt wedge estuaries. You don't even see the zero, goes all the way, fresh water, and then just as you are close to the ocean, you get this transition, the salt wedge. So now what you also get the idea is of if you have an intermittent estuary where the F number can change, you can actually get a different shape of the estuary. You might get a highly stratified estuary in some stages. In other stages, you might get a slightly stratified estuary. And from what you learned before in the lectures, should click automatically in your brain. If I say highly stratified estuary, that's the situation where you have a strong inflow and a strong outflow. There's very rapid flushing of your system. All right. Okay, we do a little bit more with it. Okay, so you have this F parameter. It's really tricky to determine it, if you look at the equation. Or is it? We work out a way that you can actually derive F without measuring the other parameters, the constant that I don't even give you that constant. We don't measure the river discharge. We don't measure the tidal volume. You can determine the value of F from the salinity distribution that you have. We do it the other way around. Let's have a look at how that works.